Hello everyone, welcome back to another AP Physics 1 practice problem video. Today we'll be going over question 6 in the MIT Physics 1 workbook. So without further ado, let's go on with the question. It says, a driver initially moving horizontally with speed v dives off the edge of a vertical cliff and lands in the water a distance d from the base of the cliff. How far from the base of the cliff would the driver have landed if the driver initially had been moving horizontally with speed 2v? So first thing I'd recommend you guys do with any physics problem is draw it out. So here we have our cliff, and then here we have our water, okay? And the car is initially driving with the velocity of v, so v meters per second. And then the car, let's say, lands over here. This would be distance d, that's where it lands. And now it's asking us for another scenario where we have the same car, the same cliff, the same water, and here it's driving with a velocity of 2v meters per second, and it lands over here a distance of something d. Now, what I'd recommend you guys do from here is anytime you guys have a physics problem involving a cliff or launching something or throwing it, I would use this equation. The delta x is equal to is equal to initial position plus v initial times t plus 1 over 2 at squared. So looking at our question, we can see that when the car drives off, since we want to figure out when it's at 2v, it's going to have an initial speed of 2v. So our v initial is going to be equal to 2v meters per second. And our initial position, we can just say it's 0 since we're only caring about after it drives off the cliff. So we can say that here it is, so our initial position will just be at 0 since that's the only thing we care about. So x initial equal to 0 meters. And then here we have an acceleration. And you guys might want to say that over here, we're going to have gravity pushing it down, which is true, but gravity is only acting in the vertical or in the y direction. So this is where we have to split our equation into the x and the y components. And as we can see that this car is traveling 2v on the horizontal axis, meaning that all that velocity is only in the horizontal. So meaning that all the velocity is in the x. So this actually be v initial in the x. And then we can look at it. And since the car is only traveling to the right in the horizontal axis, it's going to have a v initial in the y of 0 meters per second. And then looking at our acceleration, we can see that gravity is going to act in it. So we can say acceleration in the y is 9.8 meters per second squared. And then now we have to figure out what the acceleration in the x would be. But since the acceleration in the y is only just the gravity pushing it down, and the car isn't accelerating speed, it's going at a constant speed of 2v, the acceleration in the y would be 0 meters per second squared. And then the question is asking us to solve for the distance horizontally, the moving horizontally. And horizontally means x, because here, let me draw this up. We have our x and our y component. We have our x and our y. And horizontally will be in the x, meaning we only want the x components. So we only want the v initial in the x, we only want the acceleration in the x, and then we can take the initial position, but technically since it's 0, it doesn't really do anything in this sense. So taking what we know and plugging into our equation, we have delta x, which is what we're solving for, so we can keep that as delta x, is equal to the initial position, which is just 0, plus 2 times the t, so we can say that 2v times t plus 1 over 2, and here we can see our acceleration is 0, so this would be 0 t squared. And what you'll notice on this right side is since this acceleration here is 0, this whole thing can just cancel out. So then we'll have delta x is equal to 2v times t. Now that we know delta x is equal to 2vt, we now have to go back to the problem and get some early information that was told to us. As we can see over here, it says that it lands in the water at a distance d. And what was the initial velocity? It was v. So we can say that we know that if we took the same knowledge that we just did, we would end up with the equation of delta x is equal to velocity times time, right? And in this case, we know what our displacement is. Our displacement is d. So you can say d is equal to v times t. And since we can see that d is equal to v times t, we can plug this in over here to v times t. And if we do that, we get delta x is equal to 2d. And that leads us to our answer of choice C. I hope you guys enjoyed the video. If you have any questions or any future topics that you would like me to talk about, please comment them down below. And in the description, you'll see a bunch of AP Physics 1 resources that I've gathered for you guys. And I wish you guys the best with your prep.